Well, I think it's 11:02. I might as well get started. Pascal, do you just want to give a short welcome to everyone for day two?
Yes, absolutely. So good morning, everyone. Welcome to day two of the AGM. As we discussed yesterday, we're going to proceed with some presentations before the lunch break today. And then after the lunch break, we're going to try and organize some breakout groups to discuss some of the various topics that we want to focus on for these last few years as we're marching towards the end of the project. Um, yeah, and so hopefully some of you have thought about some of the information that was presented yesterday and have some suggestions for areas that we want to focus on this afternoon. If not, we will seed a couple of ideas as well. Um, yeah, and looking forward to the presentations today. And with that, I'm going to hand it back over to Irena, who I think is going to cover some of the highlights from the first day.
Yes, thank you so much. I just wanted to again welcome everybody and to thank everybody for the hard work that went into preparing the presentations. I think they were extraordinary. I've received emails of people blown away by the magnitude of work that we're doing and sometimes the complexity of the work that we're doing, but also a lot of people feeling gratified that they could see themselves within the network. So really pleased for that. I have about 30 minutes, 15 minutes for highlights and 15 minutes for the data repository update. And I want to, I'll probably take a bit more time on the first than the second, but I will be on time for Pascal to introduce the wonderful Doug McDonald. So I just wanted to kind of go back to what our meeting goals were. Again, we want to strengthen our community through sharing our progress. We want to enhance collaboration both within and across objectives, and we want to mobilize knowledge into climate action. And it's really with the lens of that third meeting goal that I gave my perspective of what I thought were some of the major highlights. And I do want to acknowledge Diego, who helped in pulling together notes as well as my own notes, which really helped me inform these 7 highlights that I'm about to share with you. So Diego is very quiet, but he does enormous things behind the scenes. And just again, thank you, Diego. So I came up with 7 highlights listening to the presentations, and basically I focused on ones that I felt had major high impact opportunities for synthesis, perspectives, editorials, and opinion pieces and that emerged organized thematically with attention to novelty, relevance, and potential for wide scientific or policy impact. Clearly, I stayed up way too late working on this, so my words are not as perfect as they should be, but I'm pretty excited about the highlights that we were able to pull together. So first highlight came about reframing unmanaged wetlands as managed wetlandscapes. And why is this a high impact? Because Canada and other nations currently exclude many wetlands from their national greenhouse gas inventories, classifying them as unmanaged. And even in the United States, as Sheil Bansal shared with us, where they do consider them managed, many are not included because of a lack of standardized protocols and processes. So this distinction rests largely on a narrow interpretation of direct human manipulation, and I think David Lobb spoke very clearly about that. However, wetlands within agricultural landscapes are routinely influenced by a direct, indirect, and passive human activities. There are a number of those, and David Lobb talked about the airsheds, the watersheds, and one of the things that I'm really interested in, a lot of the community are interested in, is this wetland methane feedback loop. So the binary managed, unmanaged framing breaks down further when wetlands are understood not as isolated features, but as part of the interconnected wetlandscapes, dynamic cascading systems shaped by upstream land use and downstream connectivity. And this is an idea that Sheil Bansal brought to the table. So failing to recognize this interconnectedness results in underestimated climate mitigation potential. And so one of the opportunities is to write an opinion or perspective piece that advocates for a new classification and management framework that acknowledges catchment level management as valid forms of influence, but also promotes a gradient approach to management status, including direct, indirect, and passive, that repositions wetlands as part of functionally connected wetlandscapes that would then emphasize not only the ecological feedbacks, but the cumulative effects, and links this reframing to opportunities for national carbon accounting policy reform and natural climate solution funding mechanisms. This synthesis could reshape IPCC guidance while improving alignment with how wetlands actually function in landscapes. I have to admit that this is work that Doug McDonald actually gave a small contract to us to start looking into. Diego led that work of that, and many of you have responded to the expert poll that he put out. I think now we're getting positioned well to be able to advance that even further and write something that could be a pretty interesting, if not provocative, editorial on this issue. And so that's one highlight that I would propose. The second highlight that really stood out to me was that beautiful image that RICO came up with. And RICO was funded by the NSERC SPG that was the precursor to the CAF project under the supervision of Tim Moore, and showing how distinct those carbon, nitrogen, phosphorus profiles were, depending upon whether it was intact, drained, or restored. And so to this second highlight, I call buried signals, the legacy effects of drainage on wetland carbon stocks and restoration trajectories. Why do I think it's high impact? Global investments in wetland restoration are accelerating, yet many initiatives overlook the carbon debt from historic drainage. And chronosequence and long-term monitoring data reveal the past land use leaves lasting imprints, not only on the carbon stocks, but on the greenhouse gas emissions. This means that wetlands with similar vegetation or hydrology today are functionally different than in terms of their climate value, depending upon their drainage legacy. And this could create what we call blind spots that complicate restoration planning, distort carbon crediting schemes, and lead to mismatched expectations around climate mitigation timelines. And so what an opportunity that could be here would be to synthesize the evidence from the chronosequence studies. And this can go beyond the ones that we've already compiled in the prairie potholes in Ontario to any other ones in Canada, if not in the United States as well. And synthesize this evidence from soil profile analysis and rewetting experiments to trace how legacy drainage alters the soil carbon composition, methane fluxes, and vertical versus horizontal carbon redistribution. Highlight the time lags and hysteresis effects in post-restoration carbon recovery, evaluate how these legacy effects bias climate modeling and offset accounting, and basically propose a decision support typology for planners and restoration practitioners that could address questions like, when do legacy effects matter most? How should baseline carbon estimates be adjusted? And what monitoring strategies are needed to detect long-term responses? And I just want to acknowledge David and Pascal presentations for inspiring that highlight. The third one is one that I've been long noodling on, and hopefully have identified a couple of people who are inspiring this to go to a whole new level. And I call it closing the carbon budget towards a full accounting of wetland inflows, storage, and exports. Why is it of high impact? Wetlands are often framed as carbon sinks, but most assessments focus narrowly on the vertical gas fluxes. That's the CO2, methane, and nitrous oxide, and missing other critical components. In reality, these wetlands function as carbon nodes embedded in the landscape with multi-directional flows, whether they're atmospheric exchanges, hydrologic inputs and outputs, terrestrial connections, and in particular, the work that is happening in the emergent vegetation zone that often gets missed, as well as the exciting idea that Pascal mentioned about the biological experts, whether they're migratory birds, aquatic insects, amphibians, that carry carbon beyond the system boundaries. So there is currently no integrated framework or tool that captures these cross-boundary carbon flows, leaving major gaps in our understanding of wetland carbon budgets and weakening our ability to include them in greenhouse gas inventories, carbon markets, and restoration return on investment models. So for this third highlight, I thought the opportunity could be a perspective or conceptual synthesis at a minimum. I do think the one on the biological inputs and outputs could be a systematic review. But if we were to put them all into one, we could do a perspective paper that maps the knowns and unknowns in wetland carbon accounting across all major inflows and outflow pathways. We could propose a framework for a 4D wetland carbon calculator. I was trying to be ambitious with a 3D one, but one that's capable of integrating multiple data types. And that would include the flux towers, the models, the remote sensing, as well as wildlife telemetry. That would call for novel methods, including isotopic tracing, organismal tagging, lateral flux measurements to quantify the underrepresented flows. And in particular, I acknowledge the biologically mediated ones as underrepresented flows. And it could highlight policy implications for offset eligibility, national reporting, and ecosystem service valuation. So I think that this piece could help focus or, if necessary, redirect monitoring priorities, tool development, and conservation investments. And again, acknowledging that this highlight was really drawn both from the presentations led by David and Pascal. So the fourth highlight is one that talks, in the world of forest and water, which is one that I also am heavily involved in. The hydrologists will often complain of the myopic view on carbon. And in conversations with Pascal and Sarah on the work that they're doing, it occurred to me that we have a similar bias when it comes to wetlands and natural climate solutions. And the idea here is to go beyond the carbon and reconciling the climate cooling and the carbon storage trade-offs in wetland ecosystems. Why does this matter? Current wetland climate mitigation policies are predominantly carbon-centric, favoring strategies that maximize carbon sequestration. And frankly, that has been my focus of all the work that I've done, both in the NSERC SPG and in the CAF. Yet the recent field studies and modeling efforts highlight a critical disconnect. The ecosystems that store the most carbon may not deliver the greatest cooling benefits, particularly through the evapotranspiration and albedo modulation. So this raises a challenge. Are we optimizing the wrong metric in restoration and conservation planning? I wanted to be a bit provocative, so I hope you get that in my tone. So this perspective, I think, could illuminate how cooling potential and carbon storage can be decoupled or coupled across wetland types and climate zones, exposing a major blind spot in global climate assessments and climate smart wetland management. Whoops. And so for here, I think the opportunity could be a synthesis paper that challenges the dominant carbon storage paradigm in wetland offsetting schemes, IPCC inventories, and nature-based solutions, and to develop a conceptual synthesis and framework that maps the functional trade-offs between carbon sequestration, evapotranspiration-driven cooling, and surface albedo effects. And this paper could argue for a recalibration of how we define wetlands climate benefit. And I put Pascal as the presenter, but really want to identify both Pascal and Sarah Knox for inspiring this highlight. Now, the fifth one, this one was about rethinking incentives and prioritizing wetland retention over restoration. Why is it high impact? Well, wetland policies and funding programs across Canada have traditionally emphasized restoration and the reestablishment of wetlands that have been drained or degraded. And I was really struck by, I knew it on anecdotal evidence, as John Pattison Williams described, including some of the living labs that we did, but his out the fact that many of the farmers and private companies don't want to really do restoration, but rather want to focus on retention. And so there seems to be perhaps a growing body of evidence that retaining extant wetlands, that means existing wetlands, especially the small unprotected ones on private lands, is often more cost effective, ecologically efficient, and socially acceptable than restoring lost ones. Despite this, most public and perhaps some private policies and incentive programs still prioritize restoration or rewetting over retention. And we talked about a number of reasons why this might be. Part of it is the restoration offering more visible or marketable results, the limited recognition of the hidden value of unconverted wetlands, which is a huge issue, challenges in proving additionality for retention, and as well, potentially institutional inertia. But on the ground evidence tells a different story. Farmers and landowners are more likely to engage with support programs focused on retention. And again, as I mentioned, some of the work that we did on reverse auctions and some of the work I believe that John and Pat and others are doing on behavioral experiments indicate higher uptake and satisfaction with retention-based programs. So avoided emissions from wetland loss are immediate, while restoration benefits often take decades to recover. And again, just emphasizing those profiles that Rico shared with us would confirm that. So an opportunity here could be an editorial or a commentary that compares the ecological return on investment of wetland retention versus restoration using cost-benefit frameworks, empirical studies, or modeled scenarios. We could highlight the behavioral evidence that shows stronger landowner buy-in and longer-term engagement with retention-first approaches. We can argue for shifting policy incentive structures, including carbon offset markets, agro-environmental payments, and conservation subsidies to better support retention, and especially retention of those small isolated wetlands on agricultural lands, wetlands with high carbon stocks and low restoration potential, and functionally connected wetlands in the wetlandscapes. And so this was inspired by Objective 5 presentation. Thank you, John, for bringing this issue up. It just reinforced a conversation, well, a comment that Pascal made in passing, but one that had really stuck with me about how much people don't really recognize, appreciate, or invest in the restoration to the degree that they maybe should. We have two more highlights just to keep you going, knowing that the end is near. Number 6, I feel like I wanted to, I felt a little bit that this, I didn't get the feedback I had hoped for, and so I'm putting it in as a highlight in hopes that maybe I can clarify the value of these wetland assessment tools and really building a multifunctional wetland assessment framework for policy and planning. Why do I think it's important? Because wetlands are multifunctional systems that simultaneously regulate climate as well as other co-benefits. But most of the current tools focus only on one dimension and often on carbon again. So this siloed approach leads to fragmented decision-making where biodiversity-rich sites may be overlooked due to low carbon scores, as an example, missed co-benefit opportunities in restoration or offset planning, and poorly optimized scenarios in municipal and watershed scale land use decisions. But meanwhile, the practitioners like the municipalities, the conservation authorities, and provincial planners are asking for tools that can integrate the multiple ecosystem functions into clear, spatially explicit, and scenario-friendly formats. So this is more than just a perspective. This perhaps is a call for those interested in working on developing the tool, but also talking about its importance. A paper that proposes a multifunctional wetland assessment system that scores wetland units across both ecosystem functions and the socioeconomic relevance. And that really came up clearly. I tried to do that in my presentation, but speaking with Je and John and others, I think there's a great opportunity to bring that socioeconomic in a bigger way. It could be deployed at local to national scales, and some of us might be familiar with the National Agri-Food Index, which is one of the reasons that the Global Institute of Food Security was supporting us. This could even feed up into that. One of the things I didn't talk about explicitly, but was inspired by John's presentation, is that we can enable scenario modeling for planners so that they can say which wetlands give us the best combined benefit under future climate or development scenarios, and offer a flexible architecture that can evolve over time. So I just want to really emphasize the tool is not just for ecologists. It's really a bridge, and it's a bridge between disciplines, making wetland science accessible by planners and municipalities, climate mitigation agencies, offset markets and regulators, as well as conservation non-governmental organizations. And so why does this matter now? I'm thinking about Guillaume and the Nature Smart Climate Solutions Fund, but also all the other major sources of funding that ECCC is putting into nature-based solutions. And right now, we need to know where best and how best to invest. Municipalities and provincial ministries face increasing pressure to integrate climate, biodiversity, and water goals, often with conflicting maps and indicators. And this framework would be able to provide evidence-based decision maker to be able to look at all the wetland co-benefits. And again, this was also inspired by presentations by George and John that really helped, I think, shape further the rationale for such a tool. And we're now back to the last one, and guess what this one's about? It's about what do we do with all that data? And so getting the numbers right, number 7, regionally specific emission factors for freshwater mineral wetlands. When we get into the National Greenhouse Gas Inventory Report, they have 3-tier systems, and the tier 1, which is the simplest, is using default values. So Canada currently relies heavily on default emission factors provided by the IPCC for its national greenhouse gas inventory reporting. However, these default values are often based on limited global data sets, overly conservative or are generic, and are often misaligned with our Canadian specific conditions. We're a big country, we have a varied geography, and we can do better than the default values that are from around the globe. As a result, Canada's GHG accounting may overestimate methane and underestimate CO2, or vice versa. And this distorts not only national reporting, but also investment decisions in wetland restoration, inclusion in carbon offset protocols, and eligibility for climate financing. And this is really the opportunity of this whole network that we could all contribute to a data-rich synthesis that compiles and compares the empirical emission data from Canadian wetlands. And I'm focusing here on the freshwater mineral wetlands, using the data from the flux towers, chamber studies, static and eddy covariance methods, the seasonal databases, and was incredible that what Gail presented in terms of the methane under the ice, especially. So I was thinking about the winter and shoulder season fluxes. Although shoulder season are not big in the prairies, they may be in Ontario and Quebec, and we'd be wanting to look at that. And of course, we can use public sources of data as well. We can analyze how site-specific variables, and the variables that kept coming up as really important were water table depth, vegetation type, salinity, and legacy drainage affect those emission factors. And we can propose regionally stratified emission factors for freshwater mineral wetlands and recommend a pathway forward for integrating them into Canada's National Greenhouse Gas Inventory. There are many reasons these are policy relevant. In fact, it's perhaps one of the reasons we were funded as a network to start with. We need accurate, regionally tailored emission factors for many of the reasons I've listed there. And I just want to acknowledge that this idea was advanced by Pascal, who explicitly called for the synthesis, but echoed by, I think, everybody throughout each of their presentations. And it has strong alignment with the work underway in objectives 1, 2, and 3. So those were my 7 highlights, and I hope that I didn't offend anybody by missing anything important. But as Pascal had said yesterday, if you have a great idea, now's the time to maybe put it into the chat, because I'll be keeping an eye on the chat and we'll be compiling them so that after the lunch break, when we go into the breakout groups, we will discuss these 7 highlights and which ones people may be excited to move forward with, but we definitely want to hear from everybody for things that are not included in these and add them to the list. So So I have 4 minutes left, and I'm going to give you a brief update about our Objective 5.1. Now, remember, Objective 5 had 5 separate um, tasks or objectives, as we call them, I guess objectives, 5.1 to 5.5. We heard from 5.4 yesterday on the Nature Smart Climate Solutions Fund extension projects. We also have 5.1, 2, and 3, and I'm going to give you a brief update on one, which was the data repository. So I want to give you a brief history in time of the major challenges in establishing a sustainable repository. We started off thinking that this would be a pretty easy thing to do, but it turned out we failed. We did not find a sustainable repository. We attempted to go to government to house it, but there was a lack of interest and there was also a capacity issues. We went to not-for-profit hosting, but they identified high upfront costs and unsustainable funding. We went to strategic consultants, and that was incredibly costly, and it reinforced the failure risk. And then finally, we thought, we're really smart. We're going to go to the CCC CAF projects like the Can Peat one and see if we can work in partnership with them. But we found incredible bureaucratic obstacles. This has nothing to do with the leaders of the Can Peat. It has to do with the university bureaucracies and incompatible IT systems. And so after 2 years of beating our head against the wall, we failed. So we pivoted. When you fail, you don't stay down, you find a new way forward. And so we decided to abandon the idea of a centralized hosting. What we did instead was create a custom web platform. We decided to host it outside of the university infrastructure because it was easier and enabled greater capacity and things that we could do with it. We have now are ready to launch it, I think next month, if it's not already there. And the benefits were not only that was it cost effective, tremendously cost effective, and just because I like to be fully transparent, we had budgeted about $350,000 to do this, and what we ended up doing perhaps may have cost $15,000 to do it. And so it's cost effective, sustainable, scalable, informative, and we were then able to use the funds released to reallocate to other members of the network who had pain points in terms of finances or exciting ideas that were not able to be funded. We worked with a startup company called Build Great, and the person we worked with was Todd Fraser. I just want to give him a shout out because I think he did a tremendous job working alongside us to be able to do everything that we wanted to do. I also want to give a shout out to Diego, who ended up compiling all the different information and put it into a structure, as you see on the left-hand side, to be able to inform the website that is now on the right-hand side. And I encourage each of you to note down the link for our website and look at it and be inspired to contribute as much information as you would like to this platform moving forward. I also want to share with you that we ended up getting the logo redone by the same company. They felt that our original logo was dated and would not have lasting power, so we decided to heed that advice, came up with this logo. And I'm hoping that someday we can replace not only wetlands, but rivers and any other kind of ecosystems and natural climate solutions. So it allows us to build further from that. I want to just share with you that we have a project site with the CAF, the 2 extension projects, but we also have the capacity to add other projects. So some of you who I know are working on NSERC Alliance grants and other things, we would find a home here to connect you to the wetlands as natural climate solutions. And this is just an example of a little bit of the content. And I'm embarrassed that Diego focused on me, but he can just go on my door and pull things off. What we really want is to hear from you and for each of you to, create a tsunami of information of the presentations that you're giving, the publications, so that we can bring this up to life. And in addition, we have impact metrics of number of downloads of presentations, of papers that we can track and will be part of our reporting system. So that's the end. I just wanted to share that brief journey, which was perhaps one of the hardest things of the network, but I think we can all take lessons learned from that. And in the end, came up with an elegant, simple, cost-effective solution that I think has staying power beyond the life of the funding of this project. So at this point, my time is up, and I'm going to pass it over to my wonderful colleague, Pascal, to introduce the next speaker.